Hello and welcome to my Sprint 3 video. Because it's loaded up, I'm gonna start with my small game update today, or this week. I have this health bar, which is just representing the health of the tank. As I get hit more and more, the health bar goes down. As you can see, the tank is an oriented bounding box, and all of those projectiles are also oriented bounding boxes, so I had that working. As you can see now, health bar is depleted, and the tank is dead. So I'll show you my schedule in a little bit, but that is my game progress this week. In the testing environment for OBB Collision, I have right here, this is the axis is slanted and it has an OBB, and here the frigate has an AABB, and the collision works on that as a just like the oriented bounding box, just as if the collision was two OOBBs. Here, if we swap out the frigate for the OOBB, we'll see they're just colliding right now, but the collisions also work. For these two, I have no idea where anything is. There it is. If we inspect these, collisions work as they're supposed to. I don't have the line segment visualizer, which would have been helpful. I just never got around to. I spent some time on it, and I was spending too much time on it, so I didn't implement that. But as we'll see right now, and this was helpful, I have a clamped point, or I have a. That's not what I wanted. I can display a point for debugging purposes in the visualizer. And so here I have on the OBB the closest point on the B sphere, the closest point to the bounding sphere center clamped on the OBB. And then the collision test is just if that point is in the sphere. Here it is, so they're colliding. As we back out, it's not. That's the criteria for the collision. So I have those working. Here's the math tools. Let's go into the bounding box. Sorry, I did this so long ago. I don't remember all the stuff in here. So this is the bounding box base class. Both ABBs and OBBs have these values. For OBBs, they are computed during the update collision data, and I believe they're also I have this prepare OBB data. Let's see, what is that? I believe that was called in here. Oh, I believe this is called math tools. This is going to be embarrassing, but I can't remember where I called that. OBB, OBB, OBB. It's not here. While we're in here though, let's look at this. This is the OBB collision. We just grab all of the vectors. We compute all the cross products. We calculate, or for every vector, we prepare the test here, and then we execute it. Max OBB projection on V is the same for both of the ABB and OBB intersections, and it is right here. And it's the same down here. Same thing, this time with type A, which is the ABB. I had a little bit of extra tracing for this one, and that is the ABB collision. Where's the OBB and B sphere? Is it? No. Here it is. This one is just moving the B sphere to OBB space, getting the center, clamping it, and then testing if that point is in the bounding sphere. Oh, this is so lame. I don't know where that. Oh, it's probably in here. Here the ABB is, it calculates its ABB stuff, and then it, computes its OBB, stuff as well. The OBB, just has, these functions. Actually doesn't need these, I can get rid of them. But, it has the visitor pattern working, and the debug view, obviously. So yeah, that's working. I don't know where that function is. I wonder if it's even called. That's so weird. Where is it? I'm crazy. What am I even looking at? Prepare OBB data. I think I never called this. That wouldn't help anyway. I promise I will not test this for too long, but I'm really suspicious that I can't find this function. Who's calling it? No one calls it? Am I not able to see it? Because I'll do it on my own terms. Regardless. It all works. And then I'll be quick because this video is going long now. And I closed it, of course. Let's just look at, of course, this is in here. So this is my planning document for the rest of the class so far. This week I set up the HUD, and the health bar, and my project was this DX demo. I'm going down the list. I have everything set out pretty basically for the game, and I'll just quickly go down the DX things. So I'll talk about exactly. I'm working on the main engine class, getting it to be my own right now, and so next week we're going to clean up the CPP file like we did in Engine 1. This week, or Sprint 5, I'm going to get everything ready to simply present the test environment with the frigate and the plane, the grid. So that is the end point of this week, so I need to get the rendering pipeline how I want it for this to be working. Sprint 6, I'm going to get the API to the level that I want it to be at. So it should be ready to mesh right into my engine, and that'll happen Sprint 7 when I port my running engine or my working engine into DX. And then the Sprint 8 is going to be going beyond what it's going to be going beyond just this port. So I'm going to be working out the lighting, and I'm going to be looking into instancing in Sprint 8, and then Sprint 9 will just be debugging. So that is that, and what I have working on now is I have this an ACL graphics class, which is like the OpenGL, not the OpenGL, the Azul Core Engine class. So I'm working on meshing this into DX. Right now, it runs with only this main window. That, and I'm merging the functions that were in main window and the functions that were in DX app into this NICL graphics file. And so once I have all of this stuff smushed into this file, then I can start pulling things out, or into this one. I can start pulling out the more complicated things and making them run the way that I want to. And just to show that this runs, let's run it. It's just going to have a blank screen, but the screen's going to show up, which is the important part. There it is. We got a screen. So that is the sprint. Hope the video is not too long. Happy grading.